All right, let's solve the next one. So same thing, first list out your possible rational zeros. So I'm looking at plus or minus 1 times plus or minus 9, and then plus or minus 3. All that divided by plus or minus 1, and that's going to equal plus or minus 1, plus or minus 9, and plus or minus 3. Well, let's take a look here. Well, it looks like negative 3 is a possible zero. So let's divide using negative 3. Right? We have fourth power. I'm missing my cube, so put a zero placeholder. Then negative 4, positive 12, and negative 9. Bring down my 1, and I get negative 3. Add down, I get negative 3. Multiply, I get 9. Add down, positive 5. Multiply, negative 15. Add down, negative 3. Multiply, 9. Add down, 0. Well, is this something that I can factor or is quadratic? Well, if this is the fourth power, this is a cube. So this is the same as x cubed minus, and I'm going to erase this, minus 3x squared plus 5x minus 3. This is a cube. Is it factorable? Factor by grouping? Actually, it's not. So I have to keep going. So this is the first time I've had to keep going. So if I go back to my list and back to my graph, was there another zero that I can try to divide by? There is. There's this guy over here, a positive 1. So divide this polynomial that you just got, your new polynomial, by 1. Bring down your 1. 1 times 1 is 1. Add down negative 2. 1 times negative 2 is negative 2. Add down positive 3. 1 times 3, 3. Add down 0. What kind of polynomial is this? Remember, if this is the fourth power, this is cubed, and this is squared. So can I solve a quadratic? Yes, I can solve any quadratic. So this is now x squared minus 2x plus 3 equals 0. Can I factor that? No, I can't factor that. Well, I know how to solve quadratics though, so we could also do this by the quadratic formula if we want. So a is 1, b is negative 2, and c is 3. Plugging in, I get x is equal to the negative of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 3 all over 2 times 1. So x is equal to 2 plus or minus the square root of 4 minus 12 all over 2. Moving up here, x would equal 2 plus or minus the square root of negative 8 all over 2. Well, the square root of negative 8 can actually be cleaned up. It's actually the same as the square root of negative 4 times the square root of 2. So I'm going to write 2 plus or minus the square root of negative 4 is 2i, and then root 2 all over 2. Well, I have 3 2's in common, so I can factor out a 2 from all 3 of those terms, and x is now equal to 1 plus or minus I root 2. So how many answers did I have? Well, it's a fourth power. I should probably have 4 answers. Let's take a look here. I've got negative 3, 1, and then 1 plus or minus I root 2. So that's 4 answers, negative 3, 1, and then 1 plus or minus I root 2. I also have to express this as linear factors. So f of x is going to equal to, well, x minus a negative 3 is plus 3, x minus 1, then this is positive, so x minus 1 plus I root 2, and x minus 1 minus I root 2. And then that's the function expressed as linear factors. Now you might ask yourself, how come I didn't put it in parentheses like I did to the one before and distribute? And I didn't actually mention that. But if you look here, I have minus a 1 plus 2i, which is over here, minus 1 plus 2i, and a minus a 1 minus 2i, and ended up with a minus a 1 minus 2i. So because you have the conjugates, it's okay not to put them in the parentheses because you're going to end up with the other one. That's only okay because you have the complex conjugates. Let's look at example 13. Last 2 examples in this section. It says, a complex root is given. Remember, roots are the same thing as zeros, which are the same thing as solutions, which, if they're real numbers, are the same things as x-intercepts. So, root equals zeros, which equals solutions, which sometimes, not always, means x-intercepts. Okay? That's only when the roots or the zeros or the solutions are real numbers. So a root, a zero, a solution all means the same thing. So a complex root is given. So a solution is given. X equal I is a root. Find all the remaining roots and express the polynomial as a product of linear factors. Okay, so find all the remaining roots. What does that mean? Find all the remaining roots means finish solving. And express the polynomial as a product of linear factors. I already know how to do that. Well, x equal I is a root. By the conjugate zeros theorem, I know that x equal negative I is also a root. All right, So what do I do first? The first thing I need to do is divide. So I goes on the outside, on the inside goes the coefficients. Notice there's no cube and no linear. So I write 1, 0, -4, 0, -5. Bring down my 1. I times 1 is I. If I add, well, 0 plus anything is just going to be I. I times I is I squared, but I squared is equal to -1. We need to have that in memory. I squared is equal to -1. So I times I squared, -1. I add down, I get 5, -5. I times a -5 is a -5i. Well, 0 plus anything is itself. And I times -5i, well, I times a -5i would be a -5i squared. Remember, I squared's -1. So you're looking at -5 times -1, which is a +5. -5 plus 5 is 0. Now remember, you're already told that I is a root, so you should be getting 0 as a remainder. Now you got to divide it by -i. -i. Bring down my 1. -i times 1, -i. I plus a -i cancels. -i times 0 is 0. Bring down my -5. -i times a -5 is a +5i. Add down, I get 0. Well, can I solve this thing? Let's see, this was a fourth power, so this is a cubed, and this is the squared. So I have x squared minus 5 equals 0. Yes, I can solve it. It's quadratic. I can solve it by extraction of roots, so move 5 over. Take the square root of both sides, and x would equal plus or minus the square root of 5. So I have four answers, positive and negative I, or plus or minus I, and positive and negative square root of 5. So I found all the remaining zeros. Now I need to express the function as a product of its linear factors. So we say f of x would equal x minus I, and then x plus I, and then we're looking at plus or minus the square root of 5. We have x minus the square root of 5, and x plus the square root of 5. So as a product of its linear factors, this function would be x minus I, x plus I, x minus root 5, and x plus root 5. And there are its zeros. The very last example in this section says the following. We need to find a polynomial of minimal degree with real coefficients with the given zeros. All right, so these are the zeros of my given polynomial. How many do I have? I have 1, 2, 3, which means that my polynomial is going to have a degree of 3. It's going to be an x cubed. I need to find the polynomial, and it has to have real coefficients. So it can't have i's in it. Well, how would I do that? Well, again, if these are the zeros, then as expressed with linear factors, this would be f of x is equal to, then minus 1 would be x plus 1. The 4i would be x minus 4i, and the negative 4i would be x plus 4i. Well, all I have to do is multiply these things and find the polynomial. Let's get rid of my i's first. Let's multiply these two together. If I do that, I'm just foiling like normal. I'm going to copy down my x plus 1 because I'm not dealing with it yet. X times x is x squared. Then I have plus 4ix minus 4ix, and then minus 16i squared. Now if I look here, a plus 4ix and a minus 4ix is just going to cancel, and negative 16i squared, again remember I squared is equal to -1, so this is negative 16 times a -1, or a positive 16. So I have f of x is equal to x plus 1, and then all I'm left with here is x squared, and then remember that was a positive 16. If I continue to multiply, I get x cubed plus 16x plus x squared plus 16. But I prefer this to be in descending order, so let's do f of x is equal to x cubed, and then I really should write my plus x squared, then plus 16x plus 16. So the answer for this, the polynomial with the smallest degree, 3 answers, so it would be cubed, that has real coefficients, because all of these coefficients are real numbers, and those zeros that were given is f of x equals x cubed plus x squared plus 16x plus 16. That's it for real zeros of polynomial functions.